So till now, the dataset on which we are working are basically linear dataset. I think it's very easy to understand. But in practical consideration, the dataset definitely is not linear. In that case, what to do? So let's check how we can use kernel now if we have a non-linear dataset. So that's why I'll come to this tab, and again you can see here that we have some set of packages we have used. So if I just run this, the package has been imported, and if you see here, this is a data where the data set is not linear. You cannot say that you can create a straight line which can classify the two classes with 100% accuracy, because one class is within another class. Just like a scenario, I hope you can remember what I have shown in the presentation. So what we can do here, if you try to make a linear kernel for your support vector machine, then what will happen? Let's see. So we are just creating some train test like here, then we are doing some fitting and then predicting y, and then I'm checking the accuracy. It's 60% accuracy. Why 60%? If you print this, you will see that the support vector machine has created a decision boundary something like this. In one side we have this set of points, in another side we have this set of points. In the right hand side we have all blue points. That is fine. But unfortunately in the left hand side we have all the red points including blue points. So naturally the classification accuracy will be very less, and that's why you can see here it is given only 0.6. That means 60% accuracy you are getting. So that means, and I hope this you can understand from this result, that linear kernel is not going to work here properly. In that case we have to think something different. That's why now let's what we have done, we have basically uh, you know so what basically we have done here, you see, we have done some transformation. If you try to do in three-dimensional space, you will see that whatever you can see in a 2D space as one set of points present within another set of points, but in three-dimensional space it's not exactly same. It's actually, there is a difference between the third axis between this set of points and this set of points. So that means if we can apply some nonlinear kernel transformation on the original dataset, then we can easily create a plane between that two different classes. And that's why you see here we have applied another kernel that I told you, radial basis function kernel. Once we apply this and run this, and then if we check the accuracy score, you'll see it's 1. Why? Because the radial basis function kernel actually transforms the data in this particular form. So just assume that you have a plane of blue dots in one layer, and you have a plane of red dots in another layer which is above to that layer of blue points. In between that two layer we can easily draw a particular plane, any plane, and if you can draw that, you can easily classify those red points and blue points with respect to that particular plane with 100% accuracy. And that is what is happening here. So just to understand this, I hope please recall the diagram that we had in my presentation. Anyway, now if you just try to plot the decision boundary, you will see it looks something like this. So with respect to 2D form, the decision boundary now looks something like this. So now I hope, and similarly if we go for another kernel, say we have another kernel poly, you can see here, and if you again check, again you will get some another kernel something like this. So some nonlinear kernel has to be there for this type of data. That's very clear from this example, I hope, right? So this is all about the the uh, coding strategy of support vector machine. And from this set of code, so what is the takeaway that we can have? That is the importance of C. Already we have seen from two different dataset the importance of the kernel function based on the type of dataset. So these and the different type of parameters that we can put within the SVC function of support vector machine for increasing my classification accuracy. So whenever you will basically write a code for support vector machine, always remember this set of uh, these are these points in mind for increasing your accuracy.